Hello everyone, and welcome to the Breathe California educational podcast series. I'm Aisha, Communications Director here at Breathe California. This podcast series is designed to educate the public on air quality and lung health related issues and to inform on the work Breathe California is doing on a variety of topics. The theme of our podcast today is Urban Biofilters, Mitigating Pollution with Vegetation-Based Strategies. We'll be interviewing Brent Bucknum, the Executive Director of the Urban Biofilter Project, and Cort Anasatcio, Professor at UC Davis from the Department of Land, Air, and Water. Thanks for joining us today, Brent and Cort. So to get started, let's frame the urban environment. Cort, could you answer on what factors contribute the most significant pollutants in urban environments today?
Thanks for having me. The vehicles are a big source of air pollutants, so that's everything from diesel trucks and cars, and if you're near the port of Oakland, ships. And the pollutants that they emit include primary pollutants such as particulate matter. So primary pollutants are emitted directly from the vehicles or ship or whatever you have into the atmosphere, and then they also emit gases that can become particles. So those are considered secondary particles. So the gases get emitted and then they can be reacted in the atmosphere and form new particles. So it's primary and secondary particles. They also emit nitrogen oxides, NOx. And NOx is important because it forms ozone. So ozone is a secondary pollutant that gets cooked in the atmosphere and made when the emissions sit for a few hours. So particulate matter, NOx, some sulfur dioxide is important. Those are really the three main air pollutants.
Thanks, Cort. So in what ways can plants remove some of these mentioned pollutants?
Yeah, so plants can remove pollutants in two types of ways. So they can remove particles and they can also remove gases, things like ozone and nitrogen oxides. They remove particles simply by when the air comes close to the vegetation and goes into the vegetation, the particles hit the leaves of the plant and most of the time will stick. And so in that way the plants act as filters for the air, and then they remove the particulate matter, the particles, and then eventually when it rains, the rain will clean off the leaves again and deposit all the particles into the ground. So that's how they remove particles. And plants can also remove gases, so like NOx or ozone. And the gases go into the pores of the leaf, into the stomata, and react there and get removed.
Excellent, thank you for sharing. Can you also speak upon any evidence through research that shares on the effectiveness of vegetation-based pollution mitigation strategies?
Yeah, there was just a study that came out last year that showed that a design for kind of urban canyons around the highways with bamboo could actually be very effective at removing particles, because what can happen is you make this canyon with green walls, and then the air circulates around in this cabin and it spends a fair amount of time in there before it moves out, and as it goes up and down in this canyon by the walls, it can remove in some cases up to half of the particles and the NOx that gets emitted by the vehicles. So there was a study done in England that showed in these urban canyons, if you have green walls and green spaces, they can be really effective in some cases if they're planned properly to reduce NOx and particulate matter.
Excellent, thank you for sharing. So with current research available showing the effectiveness of green infrastructure solutions, it's especially exciting to share that the State of California Strategic Growth Council recently awarded a Proposition 84 Urban Greening Grant to Oakland-based nonprofit Urban Biofilter. Urban Biofilter is working to develop a green infrastructure and climate change preparedness master plan that encompasses West Oakland and the Port of Oakland. To meet this challenge, Urban Biofilter has created Adapt Oakland, a project that develops standards and policy recommendations for green urban infill at both city and state levels. Adapt Oakland's infrastructure solutions include using urban forests, living walls, trellises, and green roofs to mitigate the scientifically documented health impacts of particulate matter and pollution on people living and working in close proximity to industry and shipping. And with that introduction, I am honored to introduce our next guest, Brent Bucknum, the Executive Director of the Urban Biofilter Project. So Brent, it seems that there's no shortage of benefits from plant-based pollution mitigation. So what have been some of the challenges that you have faced with implementing a lot of these strategies?
The challenge has been that there's recommendations for planting vegetated barriers, but no design guidelines or what plant lists to use or density of planting and all the parameters that a designer and engineer needs. So the first 4 months of our research project have actually been gathering the state of the science and understanding all the studies that have been done around vegetated air barriers, some of which Breathe California did in Sacramento and across the world, and cataloging the state of what we know now.
And what types of plants are known to be the most effective in vegetation-based pollution mitigation strategies?
Ultimately, as far as the types of plants that we would be using are fast-growing species. What we need is immediate, quick remediation of our strategy. What we need is immediate response to air impacts on neighborhoods and challenges. Some really good air filtration plants will take 40 to 50 years to get to 40 or 50 feet. And what we've been looking at is essentially more pioneer species or fast-growing species that will move in quickly, grow fast, and reach the heights that we need as well. So at different points along freeways and roads, 30 to 40 foot tall vegetation could work. In other areas, we need 60 or 80 foot tall vegetation. So we've also been driving the planting strategy a lot around what plants can actually be selectively harvested and sold to actually pay for and maintain and create an economy to support this. So some of the things we've been looking at are poplars. We've been looking at obviously the pine species, which grow slower but are really effective. We've been looking at bamboo as a really rapid growing option, and hybrid poplars and other plants that are being looked at a lot for forestry but also have a huge urban potential and impact. So the qualities you're looking for in plants are essentially dense foliage, because the plants are actually mechanically filtering particulate matter out. It's not a biological process inherently, but particulate matter is flowing through the plants and attaching to the leaves. And depending on both the leaf structure, if you look at more succulent plants that often grow in Mediterranean climates, they're very waxy. Problem with those, though, is that they don't have as much hairs or filament to capture particulate matter. Similarly, we look at species that will drop their leaves, because in our climate we don't get a lot of rainfall for half the year, and like another filter, a tree can actually fill up with particulate matter. All the hairs on the leaf will get fully consumed. If you go out to some of our research facilities out at the Port of Oakland right now, you'll see leaves that are completely black kind of by midsummer, late summer. So we're also interested in leaves that shed very regularly, so looking not only at deciduous plants that are shedding their leaves for half the year, but for example, species like bamboo are actually a grass, and they're constantly shedding their leaves and constantly growing new leaves. So you have the greatest surface area of clean leaf to receive particulate matter. So for us, a lot of it is looking at these sort of biomechanical features of different tree species and then designing those optimally in the wind directions and densities to maximize filtration. One of the things we found out recently too is that big lollipop-shaped street trees that you would normally imagine as a street tree can actually create worse air quality environment in the street canyon where residents and people and workers are. But taller columnar plants like bamboo or poplars actually have a lot of filtration capacity, but don't trap the poor air quality down at street level. Similarly, a lot of studies are showing that trellises and living walls have huge air filtration benefits, and those are some of the things we're looking at too, is saying it's not just about street trees, but for example, in West Oakland, we've already calculated 13 acres of concrete sound walls that could be planted. So in a dense urban environment, that's a huge real estate potential for air quality improvement.
Excellent. Thank you, Brent. Thanks for joining us today for this podcast. Thank you, Brent and Cort. My name is Aisha Gersos, and this concludes our podcast, Urban Biofilters. Thank you for tuning in, and make sure to check out our website at ggbreathe.org to learn more about Breathe California Golden Gate Health Partnership and how you can support our work in empowering communities to eliminate the causes and burden of lung disease, promote clean air, and improve public health. Because breathing shouldn't be a struggle or a risk.